Welcome to Pioneer's Knowledge Hub.
Chandrayaan-1 was India's first lunar probe, a space mission launched by the Indian Space Research Organisation, ISRO. It was launched on October 22, 2008, with the primary objective of conducting scientific research on the Moon. The mission marked a significant milestone for India, showcasing its capabilities in space technology and exploration. Mission objectives. Chandrayaan-1 had several scientific objectives, including mapping and studying lunar surface. The spacecraft was equipped with a suite of scientific instruments to study the Moon's surface in detail. These instruments included cameras, spectrometers, and radar systems, which were used to create detailed maps of the lunar surface and analyze its mineral composition. Search for water ice. One of the key goals of Chandrayaan-1 was to search for evidence of water ice on the Moon. This was of great interest to scientists because water is a crucial resource for future lunar missions, providing potential sources for life support and rocket fuel. Study of Moon's exosphere. The spacecraft aimed to study the extremely thin exosphere, tenuous outermost layer, of the Moon. This involved analyzing the composition and variations in the exosphere, as well as understanding its interaction with the solar wind. Understanding lunar evolution. Chandrayaan-1 sought to gain insights into the geological and evolutionary processes that shaped the Moon's surface. By studying the distribution of elements and minerals, scientists aimed to understand the Moon's history and formation. Key instruments and payloads. Chandrayaan-1 carried 11 scientific instruments from India and other countries, including the United States, the United Kingdom, and the European Space Agency. Moon Impact Probe, MIP. A small probe carried by Chandrayaan-1 that was released and impacted the lunar surface. It contained instruments to study the thin lunar atmosphere and surface properties. Chandrayaan-1 X-ray Spectrometer, C1XS. Developed by the UK, this instrument aimed to analyze the abundance of key elements on the lunar surface using X-ray fluorescence. Hyperspectral Imager, HiSi. A spectrometer provided by NASA. It captured high-resolution images of the lunar surface in visible and infrared wavelengths to analyze mineral composition. Moon Impact Probe, MIP. A small probe that was released and impacted the lunar surface. It contained instruments to study the thin lunar atmosphere and surface properties. Mission achievements. Chandrayaan-1 achieved several significant milestones during its mission. Confirmation of water ice. Data from Chandrayaan-1's Moon Impact Probe and its Moon Impact Probe provided strong evidence of the presence of water molecules on the lunar surface, particularly at the Moon's poles. Mapping of lunar surface. The spacecraft provided high-resolution images and maps of the lunar surface, helping scientists understand its geological features, including craters, mountains, and valleys. Discovery of widespread magmatic water. Chandrayaan-1's Moon Impact Probe discovered evidence of water molecules in the thin lunar exosphere, suggesting that water was released during volcanic activity on the Moon. Valuable data collection. The mission collected a wealth of data on the Moon's mineral composition, topography, and surface temperature, contributing to our understanding of the Moon's origin and evolution. Chandrayaan-1 operated successfully until August 2009 when communication was lost, and the mission was officially concluded. Despite its early end, the mission provided valuable insights into the Moon's composition and the presence of water molecules on its surface, paving the way for future lunar explorations. Chandrayaan-2 is India's second lunar exploration mission, launched by the Indian Space Research Organisation, ISRO. It is a follow-up mission to Chandrayaan-1, with more advanced scientific objectives and a more complex architecture. Launched on July 22, 2019, Chandrayaan-2 aims to further expand our understanding of the Moon's surface and composition. As well as investigate the presence of water and potential sites for future human missions. Mission components. Chandrayaan-2 consists of three major components. Orbiter. The orbiter is a spacecraft that orbits the Moon and carries a suite of scientific instruments. Its primary objective is to study the lunar surface and exosphere. The orbiter also serves as a communication link between the Earth and the mission's lander and rover. Lander, Vikram, named after Dr. Vikram Sarabhai, the father of the Indian space program. The lander was designed to make a soft landing on the lunar surface near the Moon's south pole. It carried the rover and scientific instruments to study the lunar surface. Rover, Pragyan. The rover was designed to move on the lunar surface, performing scientific experiments and sending data back to the orbiter. It was equipped with instruments to analyze soil samples and study the distribution of elements and minerals. Mission objectives. Chandrayaan-2's scientific objectives build upon those of its predecessor and include exploring lunar South Pole. Chandrayaan-2 targeted the lunar South Pole, an area of great scientific interest due to the possibility of water ice deposits in permanently shadowed regions. The mission aimed to study these areas in detail and understand their composition. Surface and subsurface studies. The rover and orbiter were equipped with a range of instruments to study the Moon's surface and subsurface. These instruments included cameras, spectrometers, and drills to analyze soil samples at different depths. Search for water ice. Chandrayaan-2 aimed to confirm and study the presence of water ice on the lunar surface, particularly in the polar regions. Detection of water ice would have significant implications for future lunar exploration and potential human habitation. Mapping and mineralogy. The mission sought to create detailed maps of the lunar surface and analyze its mineral composition. This information would provide insights into the Moon's geological history and evolution. Mission challenges and achievements. Chandrayaan-2 faced a major challenge during its landing phase. The lander, Vikram, lost communication with ISRO during its descent to the lunar surface. Despite this setback, the orbiter continued to function successfully and has been sending valuable data back to Earth. Orbiter achievements. The Chandrayaan-2 orbiter has made significant achievements, including high-resolution imaging. The orbiter captured high-resolution images of the lunar surface, contributing to our understanding of the Moon's geological features. Detection of water ice. The orbiter's instruments detected water ice on the lunar surface, particularly in the polar regions. This confirmation has implications for future lunar missions and resource utilization. Mapping and analysis. The orbiter's instruments analyzed the mineral composition of the lunar surface and provided valuable data for scientific research. Despite the lander's unsuccessful landing, Chandrayaan-2's orbiter continues to operate successfully, extending its planned mission life and continuing to provide valuable scientific data about the Moon. In summary, Chandrayaan-2 represents India's ambitious effort to explore and understand the Moon in greater detail, with a focus on the lunar South Pole and the search for water ice. While the mission faced challenges, its orbiter has made significant contributions to lunar science and our understanding of Earth's nearest celestial neighbor. Chandrayaan-3 is a follow-on mission to Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It was launched by LVM-3 from SDSC Shar, Sriharikota. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth, shape, payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Lander payloads. Chandra's Surface Thermophysical Experiment, CHASTE, to measure the thermal conductivity and temperature. Instrument for Lunar Seismic Activity, ILSA, for measuring the seismicity around the landing site. Langmuir Probe, LP, to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies. Rover payloads. Alpha Particle X-ray Spectrometer, APXS, and Laser-Induced Breakdown Spectroscope, LIBS, for deriving the elemental composition in the vicinity of landing site. Chandrayaan-3 consists of an indigenous lander module, LM, propulsion module, PM, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan-3 is LVM-3M4, which will place the integrated module in an elliptic parking orbit (EPO) of size approximately 170 by 36,500 km. The mission objectives of Chandrayaan-3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies are present in lander, such as altimeters, laser and RF-based altimeters, velocimeters, laser Doppler velocimeter and lander horizontal velocity camera, inertial measurement, laser gyro-based inertial referencing and accelerometer package, propulsion system, 800N throttleable liquid engines, 58N attitude thrusters and throttleable engine control electronics, navigation, guidance and control, NGC, powered descent trajectory design and associate software elements, hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, landing leg mechanism. To demonstrate the above-said advanced technologies in Earth condition, several lander special tests have been planned and carried out successfully. Integrated cold test for the demonstration of integrated sensors and navigation performance test using helicopter as test platform. Integrated hot test for the demonstration of closed-loop performance test with sensors, actuators and NGC using tower crane as test platform. Lander leg mechanism performance test on a lunar simulant testbed simulating different touchdown conditions. Chandrayaan-3 launched from the Satish Dhawan Space Center in Sriharikota Range, SDSC Shar, India, on 14 July 2023 on a mission to demonstrate new technologies and to achieve India's first soft landing on another celestial body. The spacecraft arrived in lunar orbit on 5 August. On 17 August, the lander module separated from the propulsion module and soon after began its descent to the surface. On 23 August, after a nail-biting wait, ISRO confirmed that Chandrayaan-3's lander had successfully touched down in the Moon's southern polar region as planned. The lander will soon deploy its rover. During its mission on the surface, which will last for 1 lunar day, 14 days on Earth, the rover will carry out a number of scientific experiments. ESA stations will continue to relay telemetry and scientific data gathered by the mission's rover and lander module until the end of the surface operations. Please do like, share and subscribe to my channel. Thanks for watching.